Selamat pagi Bapak Ibu yang sudah hadir. Kita akan menunggu beberapa menit untuk teman-teman join di webinar ini. Jadi saya akan berikan waktu dahulu. We'll give a couple of minutes, Ben. 1 minute for the participants to join. There's already 23% attending the webinar right now. Format kali ini adalah webinar, itu berbeda dengan Zoom meeting ya, Bapak Ibu. We'll wait until 2 minutes past 10, and then we'll start this webinar. Because there's a lot of topic to discuss, and we don't want to pass way our scheduled time. So we'll still be waiting until 2 minutes past 10. Okay, we are going to start in 10 seconds now. Oke, selamat siang Bapak Ibu sekalian. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Namo Buddhaya, dan salam sejahtera bagi kita semua. Terima kasih kepada Bapak Ibu yang sudah meluangkan waktu dan sudah registrasi ke sesi webinar kali ini dengan topiknya adalah Smart Farming, Insights to Sensors and Key Consideration. Webinar pada hari ini akan dibawakan oleh dua orang, yaitu adalah Beng Umali dan Sam Fischer. Keduanya dari ICT International, dan mereka berdua sudah mempunyai pengalaman yang sangat banyak lah di bidang agriculture ini, terutama di bidang smart farming. Nah, saya akan memulai dengan perkenalan dulu. Tolong di mute. Kalau misalkan ada pertanyaan, Bapak Ibu bisa menuliskan di kolom komen atau bisa mengirimkan WhatsApp ke nomor yang ada tertera di layar. Dan untuk slide itu nanti akan diberikan lewat email atau lewat WhatsApp yang akan dikirimkan setelah sesi selesai. Webinar pada hari ini kita akan rundown-nya seperti ini. Jadi akan ada opening dari saya dan akan dilanjutkan dengan presentasi. Nah, terus akan dilanjutkan dengan Q&A dan akan ada closing statement. Kami berharap semoga webinar ini bisa berjalan sesuai dengan waktunya dan tidak berlangsung terlalu lama. Perkenalan dulu dari PT Labodia Prima. Nah, kami memulai usaha kami dari tahun 1998, yaitu dari laboratori atau scientific instruments. Dari sana kami ada supply, kami kalibrasi, kami melakukan perbaikan, dan kami juga memberikan training. Dan per tahun 2016 kemarin, kami mulai masuk ke bidang pertanian, di mana memberikan supply, jadi menjual, dan juga memberikan training. Ini adalah kita punya usaha, jadi kita di sini sudah cukup lama ya, bukan baru 1-2 tahun yang kemarin. Dan ini adalah instrumen yang kami supply. Di sini bisa lihat ada merek dari ICT International, ada Rintek, ada Ampasis, dan segala macam. Apabila Bapak Ibu ada membutuhkan alat-alat seperti ini, bisa menghubungi kami. Dan apa yang membedakan kami dari supplier yang lain adalah seperti Bapak Ibu lihat di list yang ada di sini. Ini adalah begitu banyak observasi yang kita lakukan dari pertama. Salah satu alat yang kita jual adalah cephalometer dan psychrometer, di mana alat ini adalah alat yang one of a kind dan sangat unik. Dan ini membuka satu wawasan yang baru di dunia penelitian di Indonesia, bahkan di dunia. Dan banyak peneliti kami dapatkan itu mempunyai kendala untuk memahami alat ini gunanya apa, alat ini benefitnya apa. Dari sana kami melakukan banyak observasi, kami melakukan banyak POC kepada calon customer kami. Dan beberapa hasil yang keluar adalah paper, salah satunya adalah kerjasama paper ini dengan Sinarmas. Mereka menerbitkan paper dengan menggunakan instrumen yang kita jual. Dan ini adalah salah satu paper lagi yang terakhir dengan kerjasama dengan almarhum Ibu Laksmita Prima Santi. yaitu dengan penelitiannya menggunakan biosilika. Nah, di luar itu, belum lama ini kita juga mengadakan kerjasama dengan BRIN dan Kebun Raya Bogor, yaitu mungkin apabila Bapak Ibu familiar dengan Project Glow, itu kita juga ada terlibat untuk memantau tingkat stres daripada tanaman. Nah, sedikit preview, kita tuh menjual salah satu alat yang sangat unik dan kelihatannya one of a kind di dunia, yaitu adalah untuk mengukur tingkat stres tanaman atau plant stress level atau plant water stress. Kalau Bapak Ibu yang familiar dan mengukur soil water potensial, ini kita mengukur plant water potensial. Pendekatannya akan lebih dekat kalau kita mengukur ke plant daripada kita ke soil, atau apabila dalam konteks kita mau mengukur tanaman itu sendiri. Ini adalah kontak kita, dan silakan hubungin nomor telepon di sini atau bisa reply ke email yang dikirimkan. Saya akan memberikan preview sedikit mengenai ICT International. ICT ini adalah pada dasarnya mereka ini sebuah perusahaan yang berbasis di Australia yang mereka mendevelop instruments untuk peneliti, khusus untuk peneliti. Dan timnya itu banyak sekali peneliti seperti pada yang akan presentasi pada sesi hari ini, Beng Umali P.hd, itu adalah seorang background-nya adalah seorang peneliti. Dan alat ICT International ini sudah digunakan di seluruh tempat di dunia dan juga menghasilkan banyak paper yang kita bicara itu yang world class research lah itu. Dan ini latar belakangnya, yang dari sebelah kiri kalau Bapak Ibu lihat itu adalah Peter Kahl, Dr. Peter Kahl, founder dan juga CEO daripada ICT International sampai sekarang, dan beliau sudah lebih dari 40 tahun sepertinya mendalami bidang ini. Dan saat ini, dan beliau itu selalu menginovasi ya, dan belum lama ini sudah masuk ke bidang IoT. Bahkan kita sudah masuk, ICT International sudah masuk ke IoT sebelum IoT itu menjadi trending. Oke, sekian presentasi dari saya. Apabila ada pertanyaan, apabila ada kebutuhan tentang demo, presentasi, ataupun workshop, silahkan kontak kita di sini. Dan untuk sesi selanjutnya, saya akan langsung berikan kepada Beng Umali. Welcome, Ben, please.
Sorry, can you hear me?
Yes.
Yep. All right. Thank you, Anthony. Thanks for organizing this webinar. All right. So, and thanks for coming to all who are currently online. We have about 45 participants at this point in time. So thank you for coming. Again, my name is Beng Umali. I've been with ICT for 8 years now. And in this webinar, I'm joined with my colleague, Sam Fischer, who's on the other screen. Just wave your hand, Sam. So Sam and I will be presenting to you, the works that we've been doing over the last 3 or 4 years in relation to smart farming and IoT systems. So we thought of coming up with this topic because now IoT or smart farming has become, a trendy initiative. And so we thought there are various, I guess, iteration or different way by which people look at smart farming, but there are a lot of things that needs to be considered. Also, we would like to give an introduction of new sensors, new breed of sensors, and new breed of nodes that we have in place. So Sam will go through that in the next few minutes with us. Okay, so let me just move to the next slide. Oops, sorry. So this is the outline of the talk. I'll give a little bit of an introduction. I'll give a definition of smart farming and its key components. As I said, we'll look into or drill down on some of the considerations. I've segmented that into 2 sort of considerations for setting up a smart farm solution. Sam will provide examples or diagrams and illustrations of SNP solutions as well as on-ground applications. And then we also have some snapshot of current system, which is focused on research and academic settings. I'll skip this slide because Anthony has already presented this to you a minute ago. But I'd also like to qualify our company as a company who have a lot of networks, linked with other agencies, not only here in Australia, but across the world. So with our partnerships with, other businesses like Dosec, we have Airtos, Definium. We build our systems, but we also improve our systems and improve our offerings and systems through our collaborations with various universities. So this is a short list of primary universities that we link with, but it's a continuously evolving, network. Okay, so let's get down to business. So this slide is list down 3, dot points of what smart farming is. But if you look at the literature, there would be a number of ways by which scientists, as well as people who use the technology in defining what smart farming is. But principally, it can be synonymous with precision agriculture, and most of the of this literature, or those that are applying smart farming technology, define it as a system that uses technology primarily to increase farm productivity. So that's the end goal of using or applying smart farming in that sense. But in a more practical sense, in wherever you look, or depending on where you look, it would be, applications of Internet of Things technology, applications of drone technology, applications of robotics, depending on, what the level of advancement is present in that locality. Use of advanced machineries, whether it's, self-driving, or whether there's, applications of fertilizer or nutrients. So that's one example. Applications of artificial intelligence, whether it's for mapping or for identifying hotspots, or identifying diseases more intelligently, in a more intelligent manner. But also it's the use of smart sensors. So that's part and parcel of what smart farming is. Okay, so now what are the key considerations? Recently, an organization here in Australia has put out a guidebook of smart farming applied to horticultural applications. But across many other applications, these are, 6 items that would be that people who would like to use up the technology needs to consider. Okay, primary to these considerations would be what do they want to achieve, and would it be beneficial? If you're thinking of applying, say, for example, any of the concepts of precision farming or smart farming, would it add benefit to your current condition or to your current situation? And then, is there a particular issue or a particular concern that you want to address, and only smart farming is the way forward? And if so, then that's you think about what sort of aspect within smart farming you want to take on and build from there. One major consideration, second major consideration would be your budget and organization. So, this is applying technologies, and this would entail some capital outlay. So hardware, software, peopleware, all those things require some capital. So you need to consider whether you are in the position to acquire all those necessary input to the application of your smart farm. And then, yeah, you need to look at your organization and your existing manpower. Are there people who are capable of applying this technology on the farm, and whether or not they can be trained. So these are key consideration. This is one key consideration that you need to think about when you want to apply smart farming for your situation. Then what are the existing technologies, and what do you want to do with it? Say, for example, if you're talking about tractor, do you want that to be self-driving? Do you want some autonomy to how that tractor is operating, or do you want to simply track it down? Because those are two things that might require, in relation to the second item here, some budget. But if it's simply just tracking, you might find a simple GPS. It's quite cheap. And so if you apply that, then you might consider that as an add-on to how you can increase your productivity, or what sort of if that's a concern for your operation. So the state of the art is what your existing level of technical, what are the levels of technologies that are currently existing in your farm. And then the next one, central to this, it would be your farm conditions. So what sort of crop are you growing? Because different crop types or different crops would require different smart farm technologies. And if you're talking about combination of crops, then you need to consider that as well when you are adapting a certain type of smart farm technology. Incidental to that would be your management systems. Are you recording? Are you creating database? Are you using pen and paper, or are you using your brain power and not necessarily thinking about recording anything? So if you are simply growing a small amount of, say, for example, chili, and if it doesn't necessarily require input from smart farm technology, and if you're capable of handling its operation and its production without necessarily employing any of the smart farm technology, then I suppose you need to sit down and just basically continue what you're doing. But if there's a particular, if you're talking about scale, and if you're having issues with monitoring, say, for example, a certain disease or a certain nutritional requirement, and if you don't necessarily have the manpower to do it, then you might look into, say, for example, proximal soil sensing or proximal plant sensing. And in that way, you can infer, variability or different aspects of your farm. Next would be your IT infrastructure. So is there existing connectivity? So this is one of the key questions that we always ask customers, or we always ask people, whether there's a communication infrastructure, an existing communication infrastructure, because very important or very critical to the deployment or application of smart farm technology would be existing connectivity. Because if you're talking about communicating with, for example, with your sensor or with any of your technology that are deployed out in the field, then you need to have some communication happening within your farm. So IT infrastructure would be required. And then if there's some data that would be acquired through the sensors, then you need to worry about data storage as well. So where would you put that data? Whether it's within your farm, or is it in the cloud, or somewhere else, then you need to think about all those things when you're thinking about applying smart farm technology. Last one would be power. So all of the devices would require power, and so you need to think about how you will power those devices. So these are of critical importance, because in most cases, if you're talking about crops that are shaded, then solar panels might be not a better solution. Or if you're talking about battery systems, then you need to make sure that you know the power requirements of the different sensors that you're going to deploy. And you will have to work out a certain strategy by which you can, replenish the battery at a certain point while you're doing the measurement. Okay, so after those key considerations, there are also some practical applications or practical considerations that you need to worry about. Okay, so primary to this would be your technical skills. Are the personnel across the board technologically aware? Do they get scared of holding, a certain piece of instrumentation because they are not familiar with it, and they don't want to? They don't have, the I guess the passion to learn about the technology. So if that's the case, then it's going to be really difficult applying smart farm technology. But if you have an abundance of people who are technically adept and have experiences in utilizing technology that you can apply for the smart farm, then go for it. And then you need to think about training people as well as turnovers. So people come and go. Some would, stay much longer. Some would leave sooner than the others. So you need to worry about, training people in succession if you are worried about high retrenchment, if you like. Second would be compatibility and interoperability of your sensors. So if you're dealing with existing infrastructure and you want to build on from there, then you need to think about things, or you need to think about how you can connect one sensor or one piece of your smart farm system to the next system. Okay, so whether or not they can talk to each other, or whether you need to build up a new system for that existing sensor, or a new sensor, because some systems are proprietary. So they require specific software, for example, and they require a certain set of what do you call this? Basically software or firmware, for example. So you need to understand whether or not your existing infrastructure can dialogue or talk to a new system or a new component that you want to add on to your existing system. All right, next would be maintenance and ongoing cost. Okay, so sensors and infrastructure require maintenance. It's not once deployed, you can forget about it. And then you can expect that all things will work smoothly, but unfortunately that's not the case. So some sensors would fail, some sensors would be disturbed, or would be cables would be eaten by animals, and so you will have to put them together, um, do a little bit of troubleshooting. Some would behave unexpectedly, and so you need to think about how to deal with that. So someone will have to look into maintenance as well as upkeep of the sensors. And then the other thing would be, if you're subscribed to a front end, then you need to worry about paying subscription, and then how much that would cost you, as well as how much data would be allowed in the transmission. So these are some of the practical considerations. I might have missed one or two or several more, but across, I guess, our experiences, these are some of the key considerations that you need to worry about. Okay, so the plethora of smart farm technologies is huge. But for this presentation, again, we would like to focus on sensors and monitoring solutions for horticulture. Okay, so there are some examples here that are applied to aquaculture, but we would give you a flag when that happens. But essentially, we would also give you examples of sensor node integrated package, and then some IoT solutions. Okay, so going through, a group of several groups of sensor node integrated packages that are available at ICT. We have plant sensing, so we have sap flow sensors, we have dendrometers, frost and leaf wetness, canopy temperature, vegetation indices, and light sensors. So for sap flow, this measures or allows you to measure water uptake as well as water requirements of the crop. For dendrometry, the girt size of your plant. Frost and leaf wetness, primarily used for pest incidents, or in some cases, tolerance to frost or intolerance to frost. Canopy temperature, also related to stress. Vegetation indices, some of you might be familiar with how this works, but essentially, if you're talking about, this could be also related to nutritional requirement. So the more green the plant is, the healthier it is. And then in terms of light, if if your system or if your crop requires different light regimes, then you might need to think about how to, you might need to think about monitoring light in your system. Okay, so soil sensing, we have soil moisture and salinity, of course, for water availability, or if your site is affected by saline water. So it's a critical parameter that you need to measure. Water potential for stress, for water stress. So this is critical if you're in, say, for example, in an upland and you have free draining soil and you're growing crops that are drought stress intolerant. Okay, soil leaf temperature and heat flux. Some nutrients or some nutrients, and of course some plants would react differently to different soil temperature. So you might want to consider measuring soil temperature as well. Oxygen for conditions of for anoxic conditions or situations where your plant require good aeration and your condition is not fit for that, then this is something that you might consider measuring as well. And then soil drainage for leaching or nutrient dynamics and for other purposes. Microclimate sensing, we have weather sensors for various parameters. Here you can see a wind vane with wind speed and wind direction. There's also a temperature and relative humidity sensor here, but you can also look at a microclimate wherein it outputs vapor pressure deficit, the evaporative demand of the air. You have rainfall sensor, light meters, air quality sensors are also available. And then for hydrological sensing, we have water level. If you're talking about water tanks or dams, and if you want to measure depth of water in those systems, then we have sensors for doing that. Flow for irrigation or for measuring stream flow, for example. Water quality, I mentioned we have various sensors for monitoring water quality, which will be discussed later on. Automated sampling for various nutrients or for various pollutants. We can also do that. Okay, so Sam.
Good everyone, Sam Fischer from ICT. Been with ICT for 7.5 years now, primarily working on building out our IoT solution range and the communication layers. So we'll just take control here. All right. So I guess ICT's been in business 45 years now, and we've really always been about smart farming and improving the way crops are grown, and primarily providing instrumentation at a research level first and foremost for driving the research that is going into better growing crops and improving production, but also now filtering down into providing the technological solutions at the farm level to get the data that you really need to get the most out of those systems and improve productivity to its greatest, near to potential. So in terms of getting that data, the sensing that we're using and the sensing has not changed significantly. The way we're collecting that data is changing significantly and rapidly. So we came up with a design criteria when we started looking at how best to update our communication devices to collect data from sensors that we're already using and have been for 20, 30 years. Sensing is moving at a lot slower rate than communications. So in terms of ICT sensors and our communication nodes, we've gone and identified these list of 5 key design criteria that we needed to address in order to put together nodes that were best suited to the sensors that we want to support. So I'm going to go through each of these fairly quickly. Now I can move my screen. So specific sensor inputs, we've got a warehouse with hundreds of types of environmental sensors. We needed to look at how we provide small devices that can interface as many and as flexible solutions to supporting those sensors. So we, like a conventional data logger manufacturer, we're addressing protocols that sensors are using rather than designing nodes for specific sensors. So this allows us to connect variable sensor sets, which is fairly important in environmental monitoring because every farm and every crop type and every research question has a different demand for the sensor types that you need to address those questions. Second point was flexible connectivity. We didn't want to lock ourselves into supplying a device that only provided connectivity through one technology. So we identified a network level solution, a cellular level solution, and a satellite level solution, and have been working through support for each of those in the design of the devices. We're currently supporting LoRaWAN, NB-IoT, and LTE-M1, Cat-M1, but looking for a satellite solution later in the year to bring that out. Open data formats important to us. We don't want to lock the end user into relying upon us to supply an end-to-end solution. We want to put the data into the customer's hands as soon as we can. So data from all our devices is open format and free from proprietary level communications, which means you can take data from a node and register it on your own LoRaWAN server or your own MQTT broker if you're using a cellular-based communication layer, and take ownership of that data from the point of the network, rather than relying upon us to provide cloud-level data services and an API. Had to have adaptable power because all types of sensors require different levels of power. So it had to be fairly flexible and supply power to really power-hungry sensors like water quality probes, but also for probes that don't need a lot of power, like a pyranometer or a rain gauge. And importantly, they had to be environmentally sealed and conformal coated and pressure equalized, so it could be deployed in a really extreme tropical environment for a long term and not be prone to water damage. So these 5 criteria, what we interpreted and injected into design criteria for all our products. And because we're working with primarily researchers and I guess you'd say the mid level of tech savvy user, we wanted to package up solutions based on very common applications because they're all variants on a theme in terms of sensor suites. So we put together sensor node integrated packages, SNPs, for a range of crop types, sensor combinations. And I'm going to just give you an example of that. So we work a lot in controlled cropping and greenhouses. So we put together packages to monitor every aspect of that controlled growing environment in a pre-configured package for the grower. And how does that look? That's measuring. So in this example, we're measuring a citrus nursery. We're measuring basically their entire water balance. So we're looking at irrigation application and volume of leachate, how water is being retained within the pots. We've got growing precision scales with drains in them, looking at a weight-based irrigation scheduling. We're measuring dendrometry, outflow from the pots, microclimate, weather, and then we're measuring outputs. So water quality, which is fairly important at the reporting level. Like these nurseries have got to provide the regulator, the government, a report of how they're affecting water quality and be able to prove that, which they're doing through sensing. So as I say earlier, we're not locking users into providing a software solution, but we need to provide software solutions where customers want that end-to-end product. So we've got several software options, from a bit of licensed software that lives on your computer and can pull data down to a local driver and just display it. A fairly basic time series graph with some screens to do basic data interpretation. This is a SAP flow example where we're taking raw SAP flow data and turning it into a daily water usage. So we're taking the raw data, doing some data transformations and outputting it into a format which the user is going to get most value out of that data. And here's another example. We have preset data integrations with Eagle.io, which is a very commonly used environmental dashboarding platform. Provides some onboard data processing, alarming, so setting alarms at critical thresholds, and downloaded data. The platform we're putting most effort into developing out solutions for is a product called Eritos, where we can add value to the data in the modeled aspect. So we can take a weather station data and turn that into a Penman-Monteith ETO value for crop scheduling, irrigation scheduling, which is doesn't make sense doing it on board the device because you're adding a process and adding power at the device level. So we're taking processes that we've traditionally run on board a device and now running those calculations in the cloud. And with soil moisture and SAP flow data, ETO is giving you your evaporative demand. So it's closing out that water balance and providing you that full picture of what's going on. So that's just a few example screens. Shall skip over. So within Eritos, we've also got the ability to pull data in. So and look at microclimate forecasts. So where we can openly access forecast data from government bureaus, we can pull that in and inject that into our models and turn a weather station then into a forecast station, which is adding another layer of data and making that available to a grower to make a better decision. So if they know that their soil moisture is at 30%, their sap flow is requiring 30, 40 litres a day, and that in 3 days' time they're going to have rain, well, they might hold off on an irrigation decision. So it's closing out those loops and filling those holes in data. And really, smart farming is about making good decisions, like it always has been. People have always tried to farm smartly, but having data on the growing system is providing them information to farm more smartly, I guess you'd say. And yeah, providing them the tools at both the sensing level and the data visualization level is how we're attempting to do that. So I'll just hand back to Ben to close out.
Thanks, Sam. Yeah, so these are, I guess we're moving towards some of the examples, on-ground examples of our applications or of our systems, but focusing more on research applications. But also just wanted to give you some background about are a key or key instrumentation, and just to present to you a couple of them, which is the first one would be the sound flow meter. It's backed by about 400 journal publications, and it's been around for I think 20 odd years. So if you want to look up the technology behind it or the science behind it, I'll point you to Steve Burgess's paper, which you can download off the internet. Otherwise, if you can't access it, just let either Anthony or Ian know. The next instrumentation is a psychrometer. This measures plant water potential in situ. If some of you are familiar with pressure bomb systems for measuring plant water status, or also known as plant water consoles, this is automating that process, and we have a unit that can exactly do that. And the power of using this instrument is you can measure plant water potential in situ, and you can create a diurnal measure or obtain diurnal measurement of plant water status that provides you, response of plant as it experiences fluctuations in solar radiation, moisture content, and ambient conditions like temperature and relative humidity. All right, so just an example, a huge, I guess, deployment of our sensors. We were tapped by the Department of Primary Industries here in New South Wales. Sam has been key to the instrumentation of 12 research stations, from broadacre cropping, horticultural cropping system, fisheries, and even livestock, including chicken and cattle. So some photo dump on your right here, but this is, I guess, the geographic location across the state. So this is the state of New South Wales, and this is where these systems were deployed. So pardon the minuteness of this text here, but if you want further details, just let us know. We had works as well with precision pastures. So currently there's 24 pasture monitoring station on 11 cattle producing farms in New England. So this is area that's close to Armidale, New South Wales. So that's near the border with Queensland, primarily to measure soil moisture, normalized difference vegetation index, rainfall data, so that it can be fed on to growers and pasture consultants, because they want to improve the understanding of grazing practices, primarily on soil health and rates of carbon sequestration. So these are examples of systems that are put in place, more or less like a weather station with, of course, NDVI, and that's sort of the data that's coming off from the instrument. Also with the University of Technology in Sydney and New South Wales Food Authority, this is to assist oyster farmers monitor their oyster farms and basically look at what the data. So at the moment there are 12 oyster producing estuaries that were instrumented, primarily to look at salinity and level and temperature data. And then this would basically be input to manage estuary harvest times. So because these are critical parameters for the quality of the oysters. In a trout hatchery, that's what a trout looks like. This particular picture here is actually harvesting the eggs from the trout. But similar to the previous project, it's looking at water quality, primarily pH, salinity, and dissolved oxygen. So that's a node there that's latched onto a pontoon. And then the sensors are basically on the water level here. This one is part of the hatchery. So you got tanks here where the trout is, and so you've got monitoring ongoing as well for the different soil, for the different water quality parameters. Going further south in Melbourne, Victoria, we've tied up with Swinburne University. This is in a community garden to look at urban forest system. So a number of trees similar to this one has been was instrumented with SAF flow sensors. And this now becomes an input to a project on urban heat island effect. So this is just an example of data that's coming off from this particular tree. Going back to where I'm currently at the moment. So here in Adelaide with the South Australian Research and Development Institute, quantifying grapevine transpiration in an experimental site just north of Adelaide. So you got SAF flow sensors. This is irrigation lines. So they're looking at level of irrigation that's suitable for this climate and for this variety of vine. Another example here in South Australia, in a commercial ornamental nursery. So you have various stocks or various potted trees or potted plants, ornamental plants. But primarily because this particular system is situated within an industrial area near one of the metropolis here in Australia, or metropolitan area here in Australia, they're being always audited, or they're constantly being audited for water consumption. And so they want to look at water use, as well as simultaneously look at monitoring their stocks. So we have sensors for PAR, sensors for VPD, so that they know exactly what sort of response they can expect from the plant itself. But we've also instrumented a few plants, potted plants with SAF flow meters. Across the other side of the world, in Africa, this is a scientist from ARO, basically looking at agroforestry system and how different combinations of agroforestry tree species would impact hydrologic cycle, and how what the water dynamics is. For say example, you plant more of these species compared to less of the other species. But primarily this is for looking at how they can improve coffee agroforestry systems in Uganda. Similarly, in Vietnam, you're probably aware that Vietnam is the top producing country for Robusta coffee. So in Western Highland Agriculture and Forestry Research, they wanted to get an estimate of how much water the particular tree or certain assemblage of tree would use up. So this is an experiment that we conducted 4 years ago. In the Philippines, this is an ongoing project with Bataan Peninsula State University, funded by the national government, but primarily focusing on Philippine mangoes. So because of climate change, they're looking to transition all orchards and primary cropping systems to irrigated systems. So at the moment, all crops in the Philippines are rain-fed, but because of climate change, they need to adapt. And so at this point in time, they wanted to have a baseline information how much what these trees are using up, so they can have an informed decision about irrigation amount. And so as a result of that initiative, they were able to participate in a conference just last year in Brisbane called TropAg. So on this picture on the left, primarily just to showcase their experiences on IoT sensor deployment in the site. So a number of different sensors, including soil moisture probes, haflometer, psychrometer, and the weather station was deployed out in the field, but also looking at what sort of data that they can expect from the system. And as a result, they were able to also initiate a secondary subsequent study looking at whether if they add more to the system in terms of water or irrigation, how much would yield be impacted. And so this is what this second poster is indicating. Now, through Ian and Anthony, we are setting up a system at Bogo Botanical Gardens. So as you can see in this photo, this was just 11 days ago. But this is in Bogo Botanical Garden. A certain tree has been instrumented with SAFLO sensors. There's a VPD, a temperature and relative humidity sensor here, and a node at the back. There's also a dendrometer installed in this tree, and there's another sort of microclimate station set up on this fence, all within the Bogo Botanical Garden. And within the next few days, we hope that the data will be online. We're setting up all the front end at this point in time, but essentially this is a trial that we are starting with Bogo Botanical Garden to showcase and give us an insight what's involved, what is the challenges that we can experience when we are trying to deploy systems in Indonesia. And so this is a learning curve for all of us, primarily for PT Labodia and also for us. What sort of if you're deploying sensors and if you are building up a system for this particular environment or for this particular setting, what is expected, what are the adjustments that you need to do. Say, for example, we're talking about existing IT infrastructure. Do we go LoRaWAN? Do we go Cat M1? Do we go satellite communication system? But I think in the next few days, it'll be up and running. So we have a few successes. Ian can tell more about that along the way, but basically this is happening as we speak. So thank you very much. I think we've gone over time, but because we have a lot of information to share with you guys, and we're excited to share this information to you. So we hope you appreciate the slides and the discussions that we presented to all of you.
Oke, terima kasih kepada Ben dan Sam yang sudah memberikan presentasi. Nah, sekarang kita akan masuk ke sesi Q&A. Mohon maaf, ini waktunya sedikit molor dari schedule. Jadi, dan sebelumnya itu di email juga kita sudah menerima. Pada saat registrasi di awal, kita juga sudah menerima banyak pertanyaan. Beberapa nanti kita akan address, tetapi pada hari ini karena kita kejar waktu, tidak semua kita bisa bahas. Nah, untuk sesi ini akan dimoderasi oleh Pak Ian Sebastian. Beliau adalah dari tim teknis kami yang sudah berpengalaman keliling Indonesia, menginstal beberapa jenis sensor dan segala macam. Silakan Pak Ian.
Oke, terima kasih banyak Pak Antoni. And Ben, Sam, we have a lot of questions from our participants, but I don't think we will be able to answer all of them. But one of the most common question that they have is about macronutrient sensors, the NPK sensors. As you know, Ben and Sam, there are a lot of China-made NPK sensors that claim to be very accurate. What do you guys think about that?
Sam, do you have any?
Yeah. Well, they're measuring basically EC and relying on a calibration, a loose calibration to each of those nutrients, which is going to be so variant from soil to soil that the amount of error in that calibration is going to be significant. And often when you see the specification sheets for those sensors, they're calibrated to a red, a black, and a yellow soil. So I'm not sure what that translates to in an actual soil type, but that's the level of information you're getting on a specification sheet. It's definitely cause for concern, I'd say. There was a US company called Teralytic that tried to tackle it a few years ago with a lot of embedded learning on their device. I don't think they've had a lot of success in penetrating the US market.
So I guess that sensor is just for marketing gimmicks?
Yeah, because it's what everyone asks for. So it's just addressing a hole in the market and a technological hole in that there is not a good sensor on the market to address that. And if you're interested in those variables, you're probably better going back to a soil water sample. So putting in soil water samplers like the SEC 1900 soil water sampler, taking manual samples and testing it, and maybe developing up your own calibration scripts against a salinity measurement or an EC measurement. But definitely manual measurements are better for NPK, I'd say.
Correct.
Yeah. Thank you very much, Sam. And then, okay, one more question. How is this smart farming doing in Australia for Australian farmers? A lot of Indonesian farmers are interested of going going into smart farming, but the question is, how is it? What it is like in Australia or other part of the country of the world about smart farming? Are they already implementing it in their farms or whatever?
Yeah, go Sam.
In Australia, labour costs are very high. So you saw that the first wave of smart farming was about tackling the monitoring for labour saving almost. So water tank monitoring and monitoring your water assets was a big one, because they were traditionally assets that people had to go and manually check. So if you can monitor them, monitor real-time tank and trough levels on a sheep station or a cattle farm that you might have to drive long distances to manually check those, that was an instant ROI on labour. So I think initially it was about labour saving on those labour-intensive tasks that could be easily tackled with smart sensors. With environmental monitoring, it's always a little bit more ambiguous to define an ROI, because you're monitoring something that you haven't monitored before, and you're chasing yield gains. So any data you can get on growing that is going to be beneficial in coming years to then implement management to get those yield gains. But I'd say setting out from day one, and lots of companies will say, oh, you'll get 30% yield gains with this technology. You need to just start collecting the data to work out where the where the improvements can be made into that growing system with something like soil moisture or sap flow or weather-based data. So it's a little bit unclear, and it really comes down to, as Ben said, what staff, who have you got, and what skills have you got on staff to actually interpret that data and use the smarts within your organization to use that data to improve the production system. The machine's not going to do everything. You still need, the human is still the smarts in the smart farming. You're just providing that human the data to make a smarter decision.
Okay, so basically we humans are the one that is doing the controlling, right? Not letting the machine do all the automatic works. It doesn't work that way for smart farming, right?
No, the artificial intelligence is not there yet.
Okay, thank you very much, Sam and Ben.
But also,
okay.
if I may add, the technology is constantly evolving. So say, for example, in the advent of, 3G and 5G, previously, if we're talking about 3G, then it's simply telemetry system. So data will be transmitted, say, for example, from a trough to a cell phone tower. But now we're talking about, small packets of data through IoT, for example. So even before, so the farmers would be, left behind. The technology is already here, but they want to keep, or they want to stay in that technology primarily because, it's an additional cost, and then new learning, and then new adapted skills that they need to work out. So yeah, it's a dragging process, if you like. But of course, there's farmers that are very switched on, and so they can easily adapt, and then through government support as well, they renew or they upgrade their systems, and so that's basically happening as the technology changes.
Okay. All right. Thank you very much, Sam and Ben. I think I'll give it back to Mr. Anthony for closing up.
Can you please address the question in the Q&A session?
Okay, here you go. Here are some questions. What is your views on NPK? Are Australian farmers already using how to implement smart farming in dry lands?
No, not that
Which one? Sorry.
one. Ben, the Q&A.
Okay.
First question from Mr. Samuddin. He is asking about smart farming technology. Can it be used in an industrial plants or plantation?
Of course. Yeah.
Yes.
So again, you need to evaluate whether there's current communication infrastructure, and then also define what sort of smart farming technology you're going to adapt. So we have examples here. We're working with a number of commercial industrial companies who are producing, not palm oil. What is it called? Sandalwood oil. It's in Northern Territory. We have systems. Where else? That example that Sam presented, we've shown earlier across a state. So New South Wales have got sensors deployed across the state in various different applications. So yeah, hopefully that answers your question, Samuddin.
Yes. Okay. The next question is
from Yayat or Happy.
possible to use sensors to detect fertility and plant's health. Yes.
Okay, so health. So I suppose health of soil, soil health and plant health. So this is related, I suppose, to the NPK question. But yeah, in terms of
Yes.
nutrition or health, soil health, the current state of the art is still wet analysis, lab analysis, obtaining field samples, either it's soil solution or soil sample itself, and then analyzing that in the lab. In terms of plant, we've showcased sap flow sensors, as well as psychrometer that can be used in that regard. So if, say, for example, you're looking at plant water relations and hydrated state of the plant, then those two sensors are are available for you and can be used. You can infer other physiological processes with those sensors, as well as whether they're experiencing, some sort of disease. If you're measuring plant water status as well, so those sensors are available. All right, Sam, do you want to add something or anything?
No, I think you've nailed it there. Definitely. I mean, for industrial, for the plantation level forests, yeah, that's really where our solutions are probably used more at the large scale level, because those organizations have staff on board and the capability to make the most out of the data sets. And plant health, sap flow will be best measure of plant health.
Can you translate the question from Yayat?
Sir Yayat, okay, this is more on sap flow mirror questions. It's about coffee trees. So what is the water consumption for a coffee tree during a vegetative and reproduction stage? Are there any difference in the water consumption?
Yeah, we expect there is. Maybe I'll send you the paper that was just recently published by Joel Buyinsa. So, but this is in South Africa. He just published a paper just very recently about water consumption of coffee trees. So it can be from 1 liter to about 4 liters a day. That's because that's within an agroforestry system. So if you're talking about a plantation in an open area, it could be a different measurement altogether. So, but in if I remember it off the top of my head, the Vietnamese coffee is also using about that amount of water, about 6 liters maximum per day. It looks small, but we're talking about water consumption of trees, not the available soil moisture or water that's available for the plant. So there's infiltration happening. So if you're applying or if there's rainfall, then not all those amount of water available to it is being consumed by the plant itself.
Yes. So it's the real amount of water that the plants drinks, right? When instead of the humidity or whatever other factors that affecting it.
Yeah.
When they are using a pendant montage to do the calculation, right? All right. So the next question will.
Sorry. Ben, let me interrupt for a while. I want to show Pak Yayat regarding our observation in the past before.
Go.
Oke, buat Pak Yayat, ini presentasi kita yang kita lakukan observasi di beberapa waktu lalu ya. Waktu itu kita membandingkan water use daripada tanaman kopi yang sehat dan terkena rayap. Ini ada 2 tanaman kopinya, jadi seperti ini. Dan ini sampelnya usia 1 tahun. Ini teknik instalasinya seperti ini, pengamatan dilakukan selama waktu 4 hari. Dan ini adalah hasilnya. Nanti polanya akan jadi seperti ini. Ini di sebelah atas kiri itu ada terlihat konsumsi air sekitar 15,7 liter selama 4 hari ini. Dan per hari sekitar 4 literan. Di sebelah bawahnya, kalau misalnya kita lihat, ini adalah dia punya pola harian. Jadi apabila dia penggunaannya siap pagi, ada matahari, dia naik, terus dia turun, dan dia naik, dan dia turun. Ini yang terkena rayap. Nah, yang sehat itu seperti ini, kita bisa lihat juga polanya kurang lebih sama, tetapi konsumsi airnya lebih tinggi, yaitu sebesar 17,71 liter. Dan ini adalah perbandingannya dari day to day. Ini mungkin tidak betul-betul, ini mungkin nanti perlu dibandingkan lagi dengan data lainnya ya. Yang saya pengen tunjukkan adalah bahwa dalam pengamatan ini kita tidak bisa hanya bergantung dari satu instrumen. Nah, contoh seperti ini kita bisa melihat ada perbedaan di dalam tanaman yang sehat dan tanaman yang terkena rayap. Nah, tetapi pertanyaan adalah perbedaan ini diakibatkan oleh apa? Bisa jadi oleh karena kandungan soil moisture di dalam tanahnya itu sendiri, perkembangan akarnya, terus juga temperatur dan humidity-nya, terus luas kanopinya juga, banyak kemampuan di fotosintesis dan pemupukan juga. So there's so many things. Dan itu kenapa dalam sebuah pengamatan, apabila Bapak Ibu pengen melakukan pengamatan, sebaiknya itu konsultasi dulu sama kita. Dari sana kita akan memberikan gambaran, ini Bapak Ibu tujuannya apa? Tujuannya ini, oke, kalau itu sebaiknya gunakan alat ini, dan ini. Kenapa? Karena itu nanti akan ada korelasinya. Kita pernah itu ada 1 kali pengamatan di masa-masa awal kita monitoring safe flow. Terus ternyata yang kejadian itu adalah mendadak jam 8:30 malam itu safe flow-nya itu ada kenaikan gitu loh. Kita bingung, dan sampelnya ada 2 pohon. Kenapa jam 8:30 malam yang notabene tidak ada sinar matahari, tapi terjadi safe flow-nya itu mengalir, artinya ada dalam tanda kutip entah fotosintesis atau proses apa. Nah, karena kita tidak mempunyai data pembanding lainnya, akhirnya kita tidak bisa menjawab fenomena itu. Nah, yang jadi masalah, kadang fenomena ini kan kadang munculnya sesekali, kita tidak tahu kapan dia tiba-tiba bisa muncul. Dan begitu itu muncul dan kita tidak punya data pembanding, ya lewat gitu aja. Nah, jadi mudah-mudahan ini menjelaskan Pak Yayat. Mungkin tidak menjawab secara langsung penggunaan airnya berapa banyak, nah tetapi kita pernah lakukan ini dan ada beberapa lagi yang kita sudah lakukan. Apabila memang dibutuhkan datanya, nanti bisa dikontak tim kita. Thank you, Ben. I'll give it back to Ian. Sorry for the disruption.
No, it's good. Ian, you're on mute.
Yes. 2 more questions, Ben.
Yep.
By Mr. Wijaya. So this is more about the psychrometer question. Okay. What is the effect of plant water potential to the plant?
What is the effect of plant water? Okay, yeah. So basically, plant water potential is, if I can put it in a layman's term, it tells you the stress condition. So the measure that the instrument spits out is in negative megapascal. So the more negative the measurement is, the more drying that the plant is experiencing. So the closer it is to 0, the more hydrated the plant is, and the more the plant is able to perform its normal physiological functioning. So you want your system, or you want your plant to be exhibiting plant water potential on a hydrated state. But of course, depending on the phenological stage of the plant, some plants would require, say, for example, some drying conditions to initiate flowering. So if you are able to instigate or introduce some drying conditions during the time that it needs to flower, then you can basically measure that and pinpoint a certain threshold for the plant so that you can determine exactly at what water plant water potential you would the plant would provide, you know, robust flowerings, yeah, and yield basically towards the end of your production period. So
Okay,
hopefully
last.
that answers.
Yes, it answers the question, Ben. Thank you. And the last question will be how to implement smart farming in cattle industry or animal husbandry. I think Sam will be there.
Yeah, Sam has a few examples, I think.
Yes.
Sorry, I missed the question.
Okay, so we are talking smart farming for animals or cattle.
Yeah, so most of the work we've seen done, I know there's devices out there for cattle that'll give internal temperature for, but most of the work we've seen done is around watering and ensuring that access to water. So just water level monitoring for most of the animals and growing conditions. So for the chicken farming, we've done ammonia sensing, which would apply as well to any animal operation in a controlled environment, like a piggery or a animal farm, or if you're moving animals, ammonia and CO2. So gas monitoring really, and water monitoring. But I know, as I say, in cattle, there is internal temperature sensors, so that we can look at metabolic and breeding processes when they're calving. But definitely not our speciality. We're plant scientists. We're not animal scientists.
Yeah. Well, one classic example they've presented is the trough water trough leveling, water trough monitoring. So that could be a basic system for cattle farm. So if you're interested to know more about that, then certainly touch base for that. But yeah. All right.
Okay, thank you very much, Ben and Sam. I think that's all about the question and answers part. I'll give it back to Mr. Anthony. Thank you, guys.
Thank you.
Okay. Thank you, Ben and Sam, for delivering the session today. There's a lot of questions involved, and unfortunately, we cannot answer them all, but we will answer them eventually.
That's good.
We will answer them one by one. I have like probably more than, I don't know, more than 70 questions that.
Oh, really? Okay.
That we have. Yes, they sent it when they first register with us, but
okay.
we cannot address them all. But we will address them later on, and we will let them know that this is the answer for their questions. So again, this is only 1 hour short webinars, and probably sorry, I will explain to them in bahasa.
Sure.
Excuse me. Terima kasih Bapak Ibu sekalian yang sudah menghadiri sesi ini. Jadi memang di sesi ini mungkin tidak bisa menjawab semua pertanyaan Bapak Ibu, dan juga mungkin ada banyak pertanyaan lagi di samping itu. Dan seperti biasa di dunia saintifik, satu pertanyaan dijawab itu menimbulkan banyak pertanyaan yang lain. Nah, di samping itu, tetapi kami akan coba bantu untuk menjawab semua pertanyaan ini. Dan nanti kita akan kontak-kontakkan. Dan apabila ada pertanyaan-pertanyaan lagi, silakan bisa tanya ke kita. Kita mohon maaf apabila selama penyelenggaraan webinar ini ada kesalahan atau ada kekurangan, dan kita berharap di waktu ke depannya kita bisa mengadakan webinar ini secara lebih rutin atau secara lebih mendalam lagi. Nah, apabila Bapak Ibu menginginkan untuk workshop, kita juga bisa membuat workshop mengenai smart farming ataupun sejenisnya di tempat Bapak Ibu, atau apabila juga pengen kita visit untuk kita bicara lebih lanjut, terutama bagian di luar kota, kita bisa lakukan via Zoom. Dan akhir kata, saya mengucapkan terima kasih atas kehadiran Bapak Ibu di sesi webinar kita hari ini, dan juga thank you for Beng and Sam. A big applause for both of you as our guest speakers today. Dan kita mohon dan stay tune. Nanti kita akan thank you juga kepada Pak Ian yang sudah menjadi moderator hari ini di Q&A, dan kita akan lanjutkan lagi nanti sampai ketemu di webinar-webinar kita berikutnya. Thank you. Bye-bye.
Terima kasih.
Kita akan tutup webinar ini dalam 3, 2, 1.